Let's take a look at 5.3.5f. This is a chain rule question. It has several layers. We need to determine what is the innermost layer, what is the outermost layer, all those kinds of questions before we can really get started. So I see e to a power, and the particular power is squared as well. So a lot of stuff going on here. To me, it looks like the e is on the ground. This stuff is in the air. So the e is the outermost layer, e to the stuff, e to the x. Remember, the derivative is e to the x. So I know that the answer to this is definitely going to have e to the exact same power. So when we're doing our derivative, we start on the outside and work our way in. So we definitely want to have in our derivative something about e to the exact same power. So f prime of x is going to have, as part of the answer, e to the same thing. Okay, now working our way inside, we look for what's the next layer. I'm seeing some stuff to a power. So that power is the next layer. So if you remember, like x squared, the derivative would be 2x, right? So I'm going to go 2 times this stuff that's inside, but I'm going to change it to be to the first power because that's the way the power rule works, right? You say 2 times the x, but it'll be to the first power. You don't have to put the 1 there. Remember, that's kind of redundant, but just for clarification, I'm going to go ahead and put it there. So now that I've worked my way past the e and past the second power, I'm going to multiply by the derivative of this inside. Well, something real important here. We need to think of the inside here, this 1 over x squared, as actually being x to the negative 2. Remember, 1 over x squared is the same thing as just x to the power of negative 2. I know using Word is not the most technologically advanced thing in the world, but it's showing up okay, and it's kind of low tech for my computer, so I'm hoping it's going to work out. So anyway, I've worked my way past the e. We've done the second power. Now we're going to do the derivative of the innermost layer. And the derivative of x to the negative 2 is negative 2 x to the power of negative 3, right? Because we subtract 1. And what's the derivative of the plus 1? That's just plus 0, right? So I'll go ahead and put plus 0 for now. Obviously, that's going to cancel out, but see if it'll let me put it on the same layer. Nope. There we go. Now I'll do it. All right. So here's the outer layer derivative. Then I worked my way in. I did the next layer derivative. And then last I did the innermost layer derivative. And you remember you multiplied those all together. The derivative of the outside times the derivative of the inside. That's the way the chain rule works. All right, so now we just have to try to potentially simplify it a little bit to match it up to one of the selections. I'm seeing a negative 2 here times a positive 2. So that should give me a negative 4 in the answer, right? So negative 4 from this negative 2 and this positive 2. I should definitely have this stuff in there somewhere. Order is not really important. Remember, we can have a times b is b times a in mathematics. That was called the commutative property. Now all of this is also times this x to the negative 3. And a lot of times, remember your Algebra 1 teacher used to yell at you for having a negative exponent? A lot of times we like to write that in the denominator with a positive exponent. So let me put this stuff into a fraction. And then I'll put that x to the positive 3 in the denominator. I know we don't do that all the time in calculus because we like to see it as written as x to the n power so we can do other derivatives on it. But I think if we take a look at choice D, we can now see where everything came from. One dead giveaway always with derivatives is if you have e to a power, the e had better be to the exact same power. So that would have helped us narrow it down because it can't be like a or b for that reason because it has to be e to the same power. Okay, so I hope that clears up this particular problem, 5.3.5f. Good luck with everything.